using modules, payloads, and exploits to own a computer. We're going to do this with two different interfaces. We're going to use the MSF console and we're going to use Armitage. They both, behind the scenes, are using the same techniques to implement the attacks, and we'll see both of them in this video. And as a quick reminder, only use these tools on networks and devices where you're explicitly authorized to do so. Having said that, let's begin. I am very happy that you joined me for this video. Our objectives are simple. We're going to own this computer right here at 10.0.0.2. Now, that's the end picture. But in the process of getting there, our other objective in this video is to also walk you through the concept of using various modules with MSF console, various payloads, the actual code that we want them to execute, and various exploits, taking advantage of weaknesses that may either be injected or come from the factory in the operating systems that are running on our networks today. One of our challenges that we're going to have is that if we're working on multiple different networks and different customers, and let's say we're at this site on Monday, and we scan the network and we find these two devices, we can keep those inside of a database inside of Metasploit, which is really cool, the Metasploit framework. However, if on Tuesday we're at a different customer scanning their network, we don't want to keep those in the same exact database. So we have workspaces. You can think of them as logical sections of the Metasploit database where we can organize the discovered hosts. So when we go to a new site, what are we going to do? We're going to discover what devices are out there using a scan tool, either the Metasploit built-in scan tool, or we can use Nmap. They both work great. And then we can go ahead and decide, based on what we find, which modules we want to plug in using the command called use for that module. And then we can specify the actual payload that we want to use in conjunction with that module. And then we can specify the parameters involved with the IP addresses of the devices that are going to be involved in the attack. And then to launch the exploit, we simply type the word exploit. And then based on the module we've loaded and the payload we've selected and the host we've identified, it'll go ahead and launch that specific exploit. So let's start off by going to the MSF console by simply launching the command MSF console, and it'll take just a few moments to load. And we now have the MSF console to work from. Now, by default, when we work with MSF console, there is a database that we're working with, and it's called the quote-unquote default database. If we want to see the details of that, we simply type in workspace, press enter, and it says you're in the default workspace. We can also see some details regarding the database in general, and we can do that with the command of db_status. Now let's imagine that we wanted to create a brand new workspace, a logical section, if you will, of the database for a current customer. How would we do it? Well, just like with most everything else in the world of Linux, there is help just a few keystrokes away. It's going to give us the options for how would we create a new workspace, or how would we delete one for that matter. So as an example, let's create a brand new workspace called Test Lab 1. So it's workspace-A, the name of the new workspace we want, and poof, not only have we created the new workspace, it automatically has put us in there by default. This little asterisk right here represents the workspace that we're currently working with. I'm a big believer in verifying what we think has happened. So let's just issue the workspace command one more time, and it should show us the default workspace and the workspace that we're currently associated with. This looks perfect. Now let's say the next step that we want to take is to scan the network. Now we could just use Nmap, and Nmap will actually work from here. But if we want to use Nmap and to put the discovered results into this database inside of our workspace, we're going to use the command db_Nmap, and then we'll give it a fairly aggressive timer. We'll use the -A to say, hey, let's go ahead and throw the kitchen sink at this thing, and we're going to scan just one IP address. Now this would also work against the entire subnet. We say 10.0.0.0/24, and that would sweep the entire range, doing all the wonderful things that we learned in a previous nugget that the -A has to offer. And it is done. Now, if that didn't feel quite like the full 30 seconds, which it claims it took, that's because I snipped out about 25 of those seconds. I didn't want you staring at a screen waiting for this Nmap to complete. But now that that's done, check this out. It's now inside of the database in our workspace called Test Lab 1. Now, to see that information, we're going to use the command called hosts inside of the Metasploit framework console. And if we aren't sure what the options are for host, we can use host-h for help, and then we can issue the command host all by itself, which is going to show us that, okay, great, at 10.0.0.2, this guy's MAC address is that. It's a Microsoft Windows XP box. Looks like it may not be running any looks like it may not be running any service pack. Regarding the actual hosts inside our database, based on the scan or scans that we've done, we can also say, please show us the services. Now, the services command, just like the others, there's a -H that can say, okay, here's how you can specify additional options for the services command. But if we just want to see services, just type in services, press enter, and it's going to give us the services, the open ports that it discovered for any of the hosts inside of the workspace. All right, now for the fun part. We've identified a host. We know it has some open ports, and now we can go ahead and launch or load a module into the Metasploit. One of the things we could do is search for something specific. For example, in general, if we needed help with the search command, we could do search-H, and that specifies some of the options that we can use to go ahead and search on. So let's imagine that we've heard about this brand new vulnerability and somehow it leverages Net API. And we wanted to search for modules which included anything related to Net API. We can just type in search space Net API, and it would show us a list of modules which include that. So I've got the font fairly big, so it wrapped a little bit, but here it has the actual name. So these are all exploits, and they all have Net API somewhere in them. And what I'd like to do is let's go ahead and use this guy right here, the exploit Windows SMB MS08_067 Net API. And it has a ranking of great, which, now, great, let's use it. It doesn't mean great, let's use it. It means if it has a very high chance of success or very easy to implement. So that's what the ranking is all about. So let's go ahead and use this specific exploit. So how do we tell the MSF console that we want to load this module and use it? And the answer is, it's the same as in the previous nugget when we did the SynFlood. We're going to go ahead and specify the keyword of use, and then we're going to simply put in exploit Windows SMB and the name of that module. And you'll notice the prompt changed. So the prompt is now reflecting that we are logically sitting in that module or in that space, if you will, ready for the next set of commands. Now, with this exploit, there's a various amount of payloads that we could deliver to the victim using this exploit. And to do that, we're going to go ahead and do a show payloads, and it's going to list all of the payloads that we could potentially use with this module. Out of this large list of payloads that work with this module, we would then choose the one that we want to use. So I have a personal favorite here that we're going to try out. If we scroll up or down, if I can find this, Windows Shell Reverse TCP. And we'll scroll down a little bit farther. There it is right there. That's the winner right there that I want to use. When this payload is executed, it allows the remote device to open up a listening port, and I can connect directly to it, effectively making a covert channel between me, the BackTrack system, and the device that we're attacking. Our next step is simple. Once we've decided on the payload that we want to use, we simply tell the MSF console under the module that we're currently in that we want to use that payload, just like that. Our next task is to identify and set some of the variables that are inside of this exploit. So to take a look at what those are, we can do a show options, and it's going to show us all the options that might need to be set. So we're definitely going to want to set the remote host, that's our victim, and his address is 10.0.0.2 on the network. And we could go back to our scan to see that is his address and that he was there, but he is. And our local address, the local host, which is the attacker machine, is 10.0.0.4. And I'll verify both of those before we launch this attack. But we need to set the R host and the local host both to the correct IP addresses. So we'll set both of them. So we'll set our host to 10.0.0.2 and we'll set the local host to 10.0.0.4. And let's just take a moment and verify that we really do have the right addresses involved. So let's bring over the XP box. This is the actual screen of that device before the attack. And we'll just go to command prompt and do an IP config and just verify his IP address 10.0.0.2. That is great. And I also happen to know that the BackTrack system that we're sitting on, where we're running MSF console, does have the address of 10.0.0.4. So those parameters look good. Just to verify that all the details are in place, we're going to do a show options just to make sure that what we think we set, we did. This guy is going to become a server. We're going to connect to him. which effectively, once we have that covert channel between us and the victim in place, we can do virtually anything we want with that device. So to now launch the exploit, it couldn't be easier. We're going to type in exploit, the word, it's going to execute, and it's going to automatically generate a shell, an interface, a command line interface between us, the BackTrack attacker, and the actual victim, which is the Windows XP box. So this is interesting. It started the attack by going to port 445, which was the SMB service port, and then it spawned off a new listening port of 1047. So from our BackTrack machine, this is us. We're connected on source port 444 over to 10002 to port 10047. And this, my friend, is the literal command line interface of our victim. Now we can execute any commands we want to right here. For example, in a Windows box, if we want to clear the screen, we type in CLS, press enter. It does the same thing here. If we want to move around in the file system and don't want to be stuck in this system32 folder, we can just use the CD command. If we want to take a look and see the file system there, we can do a dir. That'll show us all the current files in that current folder that we're in. If we want to make a brand new folder, we can use the make directory command, mkdir, and then the name of the new folder that we'd like to create. We could go ahead and change and go into that directory if we wanted to with a CD space and the name of that folder, just like as if we are sitting on that local victim's machine. Another Windows command that we could issue would be like route space print to verify what the routing table looks like on this device. And we could also use netstan. I like to add the -an. That'll show me all the ports, and also it won't bother trying to do name resolution. So netstat space -an will show us all the ports currently in use on this system. So if we take a look at the ports, the interesting part here for me is that we've got this port right here, 10002, 1047. That's the channel we just established. And it's going to this machine, 10004. That's the BackTrack system at port 4444. That's currently an established session. And on closer inspection, I have a whole bunch of additional ones up here that were from previous validations as I was preparing for this demonstration. Now, to get out of this shell, we're going to do a Control-C. It's going to say, do you want to abort this session number 1? I'm going to say yes. And I'm back to MSF console at the same position before I actually typed in the word exploit. To exit out of here, we can simply type in exit, and that will take us completely out of the MSF console. What I think would be fun for us to do is do that same exercise again, but this time use Armitage. Armitage is simply a front end for Metasploit framework. So on BackTrack, I've logged in as root. I've launched StartX for the graphical user interface. We're going to bring up a command line interface and simply type in Armitage. And that will launch it. It'll automatically prompt us for connecting and starting everything it needs to function. And this will give us the opportunity to work with the graphical user interface as a front end to Metasploit. Now on the BackTrack system, it doesn't always do this, but it's asking me about what is your current IP address. So I could bring up a command line interface and verify that. It currently is 10.0.0.4, so I'll supply that information, click OK, and now it's ready for me to go ahead and launch the attacks. Just as before, we've got the MSF console interface down here, and then we have the GUI interface up here that we can go ahead and play with. So how do we get devices into the Armitage graphical user interface? First of all, we're going to go to host and say we can import them, such as an Nmap or something to that effect, or we can just launch an Nmap scam right here, and it'll do it. So let's go ahead and do a quick scan OS detect, and then specifying who do you want to attack or who do you want to scan. And we'll say 10.0.0.2, press enter, and it's off to the races using these really cool Nmap traditional options right here. And check it out, it's doing the DB underscore because it wants to add that to the database that Metasploit can then use over and over again. So it's finished. It took 17 seconds. It says based on this, it says, okay, congratulations, use attacks, find attacks to suggest applicable exploits for your targets. This is so cool. So what they did was, based on what they found with the scan, it can recommend various types of attacks which are applicable or might be applicable to that victim or potential victim. So we'll click on OK for that and check it out. There's our 10.0.0.2. So the Linux is going to show up with a little penguin, and other types of operating systems based on what they are might have a different logo. And we can also tweak and tune that as well. So if we do more advanced scans, we find more details about that platform, it can more correctly identify the operating system. But it nailed it. That really is an XP box sitting right there. So we can go ahead and move this around. If you have lots of devices, you may want to choose a view that has them in rows instead of as icons. But our attack earlier, we loaded the module of exploit Windows SMB and the one called MS0867net API. So we could do that this way as well. We could go ahead and open up exploit. And under exploit, we can go down to Windows. I'll scroll down to Windows. And under Windows, SMB, which is right here. And then in our SMB, we had several options, and we're going to choose the option of MS0867, which is right here, the Net API. So if we double click on that, we can go ahead and put in the values, and we're good to go. Another way of doing a very similar thing is this. Instead of launching it, which we certainly could do, we can go ahead and go under attacks and say find attacks. And what this will do is say, okay, based on the host in your database, and because I know it's Windows XP, let me go ahead and find a bunch of attacks which might be appropriate. So we'll click on find attacks, and in just a moment it's going to come back and say, great, I have loaded up a bunch of attacks that might be applicable for that device. Simply use the attack menu associated with that host. So it makes it very, very simple. So I'm going to click on OK. Now I can just right click here and check this out under attacks, SMB. Here's all the ones that it thinks might be likely to work on that platform. And sure enough, there's our MS0867 Net API. So to launch this, I can just click on it, specify the local host, which is already in because it knows who the BackTrack system is. The R host, it knows it's 10.0.0.2, so it already pre-filled that. And I can just go ahead and launch it by clicking on the launch button, just like that. The attack is going to open up in a separate window down here, and it's now succeeded. And we now have this thing called Meterpreter, which is a meta interpreter. You also may have noticed that this icon changed to red with lightning all around it to visually imply that this device has now been compromised with our exploit. So down here, very similar as before, we have the ports involved. So it's our local port 49,130 going to the victim at 13,846, any port in a storm, as long as we have that connection. And now this interpreter actually gives us some additional options and functionality, which are pretty cool. Now the question is, okay, Keith, how do we use them? With MSF console, we simply were given the command prompt at the victim's machine. How do we use it here? Well, to leverage this, we go back to this machine, right click, and see this interpreter right here? We have the options of access, so we can migrate, escalate privileges, steal tokens, dump hashes, persist, pass session, interact. Let's go to interact. So if we go to interact, say, I want a command shell. Click, and it's going to open up a new tab with our command shell once again. Another really amazing concept is hopping applications. For example, right now, we have compromised a service called Service Host on that Windows XP machine. That was our initial attack and what it leveraged. However, if we want to move that to another process and keep our connectivity, we could migrate from that application to a different one. To do that, we simply right-click on the host. Under Meterpreter, say Access, Migrate Now, click on that, and it'll say, oh, you were on service host process ID, blah, 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 blah. We'll migrate you to notepad.exe process XYZ. Now, I've already done that once on this system. I'm going to go ahead and migrate again to another application. So I clicked on Migrate Now, and now it's saying, okay, you were on Notepad, Process ID 540. Now I'm migrating you over to Process ID 1700. So if we were to look at Task Manager and take a look at all the processes running, we would definitely see notepad.exe sitting there, which to the average user wouldn't seem like a big deal. Okay, Notepad's running somewhere in the background on this system. Unless, of course, it wasn't really running and it was a malicious person connected to that process. So we'll click on OK to dismiss that message, and we still have our connectivity. One of the benefits of Armitage is that it helps you sort through all the attacks that might be applicable to a device. So instead of having to search a list and loading the right module and the right payload and everything else, we can simply go to Attack, specify the detail we want, and then go ahead and launch it. We can also do a check, just to check before we actually launch the attack to verify that that exploit might be viable and workable on that system. Another really cool option is, let's say that we've compromised this system, we're going through a firewall or two, maybe it's a few hops away, and we're just wondering, hey, I wonder who else is on that network with that device. We could right click and simply get a lot of information from this host. For example, we could go to Meterpreter again and go to an ARP scan and see what's in the ARP cache of this device. So we launch it and click on ARP scan, it'll bring up a new window for us. It's going to show us, okay, here's everything in the ARP cache of that host. He knows about 10.0.0.4, you bet he does, that's us, we're the BackTrack device. He also knows about this guy right here, 10.0.0.1, which happens to be his default gateway. He also knows about 10.0.0.2, which is his own address. And he also knows about 10.0.0.55, which is another computer that is sitting on that same subnet. So a lot of information can be gathered about other devices, and it started to put up icons representing those. If you don't want those in the database, you can simply right-click on them and say host, I want to remove it, and host and remove it, and host and remove it, and it will remove those. If you want to remove all the devices from the database, from the workspace, you can simply go to hosts, clear database, and it'll simply remove all the devices from the database that Metasploit is currently working with. Again, Armitage is just a really great, in my opinion, front end for the tool called Metasploit and the framework that surrounds it. I've cleared out the database in Armitage because I want to share with you one additional feature that's pretty darn cool, and that's like a last-ditch effort. If you're not sure exactly which module or which exploit or which payload you're supposed to be using, this is a method that can be used mostly as a last-ditch effort to try to compromise a system. And to do that, let's go to hosts, and we'll say we want to do an Nmap scan, and let's go and do a quick OS detection of 10.0.0.2. I've also rebooted that victim, so he's nice and fresh, and there shouldn't be too much still running on him from any previous attacks. Now that that's complete, we'll click OK. We'll get our icon for that device right here. You'll notice it's not red and lightning bolted yet. We'll fix him in a moment. And we're also going to go to attacks and say find attacks. So it's going to take this device, which it knows it's Windows XP based on the scan, and it's going to identify, hopefully, relevant attacks for that device. So we'll click OK. Thank you very much. Now we could right-click right here and say attack, but which one do we issue? I mean, we could try them one by one, I suppose. Another method of launching a whole bunch of attacks, which is not very stealthy, but it is a lot of fun, is use this option right here under attacks. Use the Hail Mary option. So we'll go ahead and launch that. And it finds the exploits via local magic, and it said it found 21 exploits, and now it's going to launch all 21 at this device, which it's amazing. All we need really is one that works, and then we can get remote access to that box and then do whatever we want from there: privilege escalation, keyboard logging, etc. So now it got it. It had some success in compromising that system. Let's right-click on this device. And it has two, not just one, but it had two different attacks that were both able to open up Meterpreter sessions with it. So all we really need is one. So let's go to Access. And before we do the migrate now, let's go ahead and bring up our victim just to take a look at what processes are currently running. So we'll bring in our victim. Here he is right here. And we'll right-click. We'll go to Task Manager. And in Task Manager, if we go to the actual processes that are running, we'll sort them alphabetically. There they are. And one of these service host guys is currently asked. So we're going to migrate it. If you'll notice, Notepad is not running on this device. So alphabetically, it would be somewhere in there. So we'll go back to the attack machine. We'll say, I want to go to Meterpreter. We'll go to Access, Migrate Now. And it will automatically says, poof, okay, I'm going to migrate you from service host process ID 1168. And now you are Notepad. So if we go back to this machine, all of a sudden, magically, there's Notepad that's running, which is now running with its open ports, allowing us to go ahead and maintain our connectivity with that device. Now, it gets even better than that. So I'm going to click OK on there. I'm going to right-click on this guy, and let's do this. As far as Meterpreter, let's go ahead and interact. So we can do a command shell. We've done that already. How about this? Let's go ahead and do Explore. We could browse the file system. Great. So it opens up a new window, and right here is all their files. Great. So we can navigate their file system and take a look at all their files. If we want to go back to Meterpreter and go back to Explore, we can go ahead and say, I want to see your keystrokes. Great. So now we're going to do key logging. So we'll click on Launch on that. A new window opens up, and we'll go back to the attack machine. It doesn't really matter where we type in on the victim machine, whether it's a browser or a word processor, because that's all those keystrokes are going to be recorded by the actual MSF console. So let's give it a whirl. Let's go ahead and let's open up a browser. I think I've got internet access still, so we'll go to google.com. And we're trying to go to google.com. I need to verify my default gateway and DNS and everything else. But if you'll notice, regardless of our success in getting to that website right here, it recorded it. It said, okay, keystrokes typed in google.com. Let's try another application, one that we don't have to rely on internet connectivity for. Let's go to Notepad. There we go. So Notepad, this is a very secret password or a passphrase or something to that effect. So we type that in inside of Notepad and check it out. It got all of that right here. So, and even got my backspace. So this is a T, and then I had a backspace, very secret password. It captured all of it. And there's the actual file that it's going to store it. So I can go back to that file and get everything. So any passwords or anything else this person is typing in, I now have them. And that's a very serious compromise for any system for keystroke logging. One other one, which is a lot of fun too, is we'll go to Interpreter, we'll go to Explorer. Now I don't have a webcam on my virtual machine, but if you want to get a picture of the guy who's sitting at that computer, you can do that as well. We'll go ahead and do a screenshot. And we'll get a screenshot of whatever's currently on that machine, which is right here. And that opens up in a separate window as well. So you can see how the Hail Mary attack, we could do all those other options through one interpreter session, by the way. But if we're not sure which exploit might work against a given device, using the Hail Mary option is a significant method for discovering what might work against a target. In this video, we've taken a look at working with MSF console using the interface provided by that by taking a look at the workspaces, scanning for devices, loading up modules, specifying the payloads we want to use, setting up variables, and launching the attack. We also took a look at using the graphical front end Armitage to do the exact same attack. And we also discovered that using Armitage and some of its automation tools can make the process of deciding what vulnerability would work against the system that much quicker. I've had a great time. I'm so glad you've joined me. As in all of these videos in this set, please make sure that you are authorized to use a tool before you attempt to go ahead and use it. I've had a lot of fun. I hope this has been informative for you, and I'd like to thank you for viewing.